Hello. In today's video, we're going to go over a proof of why every convergent sequence is bounded. So this is part of Real Analysis, and I'm following the Udemy course by the Math Sorcerer on Real Analysis. I highly recommend it. It's very nice. However, one thing I noticed with these proofs is that it might help if there's a layman's term explanation of them. So I'm going to go through and pick YouTube videos that do a rigorous proof and then provide a companion video with a layman's term explanation. And this one's going to be the Math Sorcerer's video on this. I'll link it in the description and you can go check that out. You might want to watch it before watching this and go back and forth between them. I don't know. It's up to you. Anyways. Okay, so first, what does it mean by bounded? What is bounded? Well, you think of bounds, something that's around our sequence. So that means that there's a maximum and minimum value of our sequence. That would make sense. If our sequence converges to a certain value, it's not going to diverge to infinity, which would be the case that it doesn't have a maximum, or negative infinity, which is no minimum. So that's what it means by bounded. Okay, and then we can get into how we prove this. What's the actual proof? So how do we reach the goal that a sub n is less than or equal to m up here? How do we reach that goal? Well, the Math Sorcerer splits it into two parts. One of them we can pretty easily do already, and it's saying that there is a maximum up until an arbitrary value, let's call it a sub capital M. That was an N, capital N. So up until that a sub capital N, there's definitely a maximum value, and we know that because this is a finite set of values, so you can find a maximum in it. So if we know there's a maximum up until then, all we have to do is figure out is there a maximum after that. That's where the limit definition comes in. So the definition for a converging sequence was that for all n greater than our big N, so for all n greater than our lost value in this sequence, we want the margin from those a sub n's to our limit to be within a certain error margin, and then we can say it must converge to that limit if every single value after this m here, this capital N, if every single value is close to our limit, arbitrarily close by an amount epsilon, then we can say it converges to that limit L. So how do we use this limit definition to prove that after a sub capital N, again it's this here, that after that value there's a maximum? Well, it's kind of intuitive that because they're all within a certain margin of epsilon, that they're not going to diverge anywhere, right? But we need to provide a more rigorous proof of that. So what the Math Sorcerer does is he does some inequalities, algebra. You can watch his video, and he basically gets to the fact that a sub n is less than 1 plus the absolute value of L. okay? And that's our error margin plus the absolute value of L. So if that's true, then all we have to prove, this is the second part, is that there is a maximum that exists from a sub 1 all the way to a sub capital N, and include all of the limits plus that certain margin. And if our a sub lowercase n is less than all of these values, or equal to it, obviously, because it's going to be one of those values. If we can prove that, then you've proven that a convergent sequence is bounded. Okay, so let me go over that again and summarize. I think the key point is understanding this last statement right here. So we know there is definitely a maximum value from a sub 1 all the way to a sub n. We know there is a maximum value, and we know that any number in our sequence is going to be less than or equal to that value, because they are the sequence numbers in our value. What is this strange absolute value of L plus epsilon? Well, our limit definition said we wanted every value after this a sub large n to be within epsilon of our limit, okay? And we know that they are, because this sequence converges, right? So this right here, this set, is every value in our sequence up until capital N, and then kind of a rooftop. No number can go over absolute value of the limit plus epsilon after a sub capital N. No value can go over that by the limit definition, right? So we've proven the entire sequence of a sub little n's must be less than or equal to all of these values. And that's pretty much the entire proof. I hope that helped. Go look at the Math Sorcerer's video for the rigorous proof, and come back if you have questions. And I'll see you in the next one.